My name is Chad Scribner, and we'll be going over Newman projections for Chem 2340. For this video, we have to convert this Newman projection to a skeletal perspective. Now, if we want to retain the stereochemistry of this molecule, we can't go directly to the skeletal perspective. We have to first go to Fischer and then go to the skeletal perspective. In order to go to the Fischer projection from a Newman, we have to go from the staggered form to the ellipse form. Now, to do that, I rotated the back carbon this way. I did not touch the front carbon, only the back carbon. Now that we have our ellipse Newman projection, we can go to the Fischer projection. In order to go from the Newman to the Fischer projection, what we do is we look at this from the bottom. If we look at this from the bottom, we can see that these two carbons will line up and that these two groups, you can see that we're going to be rotating this thing 90 degrees that way. And you can tell that this hydrogen will be on top here. This will be the front carbon. This will be the back carbon. And then this group will be the ethyl group. Now, do we go left or right for these groups? If we are only rotating this way 90 degrees or looking at it from the bottom, this methyl group is going to be on the left. Therefore, the chlorine group will be on the right. And the same thing with the bromine and the hydrogen. This is the configuration for a Fischer projection, which may help you see the transformations going on here. So now that we have the transformation from the Newman to the perspective, we can then determine the stereochemistry of our asymmetric centers, which are these two here. For the top carbon, we have R. And then for the bottom one, we have S. Now that we have our stereochemistry, For our Fisher projection, we can then go to the skeletal perspective. The best way to go from Fisher to skeletal is just to draw the skeletal with the correct configuration. That way you ensure that you will get the configuration correct. We have 5 carbons here. On the second carbon here, we need the R configuration. For this third one, we need the S. On the R, we have a chlorine and a hydrogen. For this one, we have a bromine and a hydrogen. For the stereochemistry and the priorities, we have this. This will go as R, so we can keep H in the back. For this one, we have 1, 2, 3, 4. This will go as R, so that means we need bromine in the back instead of hydrogen. Now on to the next molecule. To start, we need to go to the eclipse form. I will rotate the back carbon this way. I will keep the front carbon the same. And then again, to go to Fisher, we are going to be looking at this from the bottom. So we can see that bromine is going to be here at the top on our front carbon, right here. Hydrogen is going to be at the bottom. Now, for the front carbon, we have a bromine, hydrogen, and hydroxy group. Here's our front carbon. Hydrogen is on the left, so we'll keep it on the left. Hydroxy is on the right. And the same thing for the other carbon. Now we have to determine the priorities. We have a choice between bromine and a hydroxy group. Bromine is heavier than oxygen, so it will get a higher priority. Our first carbon will have the absolute configuration of S. For our second one, we actually have this carbon as the top priority because we have 3 carbons. This one has 3 hydrogens, so it will be 3, like always. 4 will be hydrogen. We have an ethyl group, or we have a carbon with a bromine, oxygen, and hydrogen. So this carbon is going to win because oxygen and bromine are both heavier than 2 hydrogens and a carbon. And if you'll notice, we didn't even need to do a flip because 4 is already on the bottom. Now we have S and R for absolute configurations. Now we can convert to skeletal. For our skeletal form, we are going to have a 5-carbon system. However, our parent chain is only going to be 4 carbons long. On this first carbon, we have a bromine, hydroxy, and a hydrogen. So I will just put the bromine as a solid line. And then I will determine between the hydrogen and the hydroxy if it will be towards or away from me. For this one, here's our ethyl group. So we either have the hydrogen or the methyl group. For this one, we can see that we need S. So if we were to keep hydrogen in the back, we would get the S configuration. For the other carbon, remember this one had the number 1 priority. So this will be S here, the same counterclockwise motion. So we need the methyl group in the back, not the hydrogen. And that concludes the video for Newman projections.